So in the next few slides, we're going to look at 8.2, how do we find a confidence interval for the population mean when we don't have sigma, when we just have the sample standard deviation. So this is pretty similar right here. We have x bar in the middle, plus or minus the EBM, but the EBM formula is slightly different. What changed? Well, instead of having z here, we have a new letter called t. T is not that different than z, but it's a little different. And I'll explain a little more about that, but you probably won't understand my explanation terribly well, and I'm sorry for that. It's just hard to really develop in this course, but t is different, and then notice that sigma is replaced by s, which makes sense because we don't know sigma and we do know s. So again, the formula has the same form. Instead of z sigma over root n, it's t times s over root n. So we'll go through the process again where I will give you the information that you need. Sorry about that. I'll give you x bar and the confidence level and s. And then you will need to know the degrees of freedom, which is just n minus 1. And you might be like, what is degrees of freedom? Well, df is degrees of freedom, and it is one of the things you need to know in order to find t. So remember, before we started with a confidence level and then we figured out the z-score that it would point to. Now we're going to start with a confidence level and we're going to find the t-score that it points to. But the t-score will also require us to put in the degrees of freedom. Once we have the t value, then we can find the EBM, confidence interval, and interpretation. So what is we want a little more information about the t distribution. And when you have a small sample size and you only know s, this guy, William Gossett, discovered or invented the t distribution. He couldn't use a normal distribution or z-scores because his sample size was too small. So we'll just use the t distribution with a parameter degrees of freedom. Here is a graph of what the standard normal distribution looks like, and then what the t distribution looks like when you have n close to 30, and then as the sample size gets smaller, the t distribution is more spread out, which just would mean to you that there's more possible variation. So the z distribution is the best because it gets us closer to the mean. And the t distribution, we have to use it in certain cases, but it's going to produce a wider confidence interval. So for the z distribution, 95% confidence goes from negative 1.96 to positive 1.96. And for example, if we had a sample size of 12, then our t distribution would go from negative 2.2 to positive 2.2, so slightly wider. And we can find the t values. So before we had a little table to tell us the z value to use based on a confidence level. And we will have a different table to tell us the t value based on a confidence level. And so I'll talk more about that. But the problem is that the t distribution has different values based on the sample size. So if the degrees of freedom is 6 or 3, we have a different t distribution. If we have a really large sample size, then the t-distribution basically looks like a normal distribution. So if degrees of freedom is infinity, then that looks like the bell curve, the normal distribution. And I'm going to stop right here and show you an example of using the t-distribution to create a confidence interval.